Good morning. Today we are going to discuss about an important topic, the time value of money. The time value of money is the principle that money available today is worth more than the same amount in the future, primarily due to earning potential. We may get the yield in the form of interest or investment returns and the erosive effect of inflation. The time value of money is important. Earning potential, as I already told you, inflation, and you have to think about opportunity cost also. By delaying the receipt of money, you forego the opportunity to invest it and earn returns. Key component, there are many key components. One is present value, expressed as PV, future value, FV, interest rate, and time period. So let me go in deeper. That you have a detailed analysis related to that. Just look into the picture given in this slide. You need sufficient income from where in which you will deduct all the expenses. You will meet out all the expenses from that. Remaining amount will be a surplus you'll have. That typically we used to say savings. If you keep that savings with you, okay, it's not going to benefit you. So either you may take that one into the bank or any other investment firm. Once you are put in a productive investment, that's called investment. When you have multiple such type of investment options, say investing in securities, investment in bond, gold, real estate, put together it is the safe portfolio. What you're seeing it here. And please remember what are the earnings you are going to get it. It should be sufficient. At least the minimum rate of return you must be in a position to get it. In addition, the earnings what you're getting, that must have a cushioning effect for inflation. Suppose the inflation rate is 5%, and if you expect minimum 9% from your investment, automatically minimum what you are supposed to get is a 14%. 9 plus 5, that is equal to 14%. Let me start with a simple example about future value. As I already told you, FV stands for future value and PV stands for present value. As far as this example is concerned, which is coming under single lump sum amount, you invest 10,000 today at 5% annual interest compounded annually. How much will you have in 3 years? If you make an investment of 10,000 rupees today with a 5% annual interest, after 3 years, how much you will get? The formula for calculating the future value is equal to present value into 1 plus r to the power n. Here the present value, how much money you have right now, 10,000, and rate of interest is 5%, which will be expressed 0.05, and number of years 3 years. Just I am going to substitute the value PV 10,000 into 1 plus R, it's 5%, which is nothing but 0.05 to the power 3. So you'll get an answer of 11,576. Now look into the same picture. Here the time factor is applied here. The earlier the income will flow into our pockets, the sooner we can invest it and make it grow. And when you convert all the savings into investments and subsequently multiple investments, okay, that will result in portfolio. When your portfolio is well managed by balancing both and risk and return, and in long term it will lead to leads to creation of wealth. I think this picture will tell you the entire story about that. Let me have one more simple problem. to calculate the present value when you make a single lump sum investment. You need 20,000 rupees in 3 years. Interest rate is 6% annually. How much should you invest today? So to earn 20,000 rupees in 3 years, how much I am supposed to invest today? Here the formula will be using a slight change in the earlier one. Present value is equal to future value divided by 1 plus r to the power n. Where the same thing, okay, we'll be using it. One FV, the future value expected amount is 20,000 rupees. Interest rate 6%. Again, if you convert, it will be 0.06. And the waiting period 3 years. Investment period is 3 years. Just you're going to substitute the value 20,000 divided by 1 plus 0.06. That will become 1.06 to the power 3. So 20,000 divided by 1.191016, which is amounting to 16,793. So this interpretation, okay, you're going to make it 16,793 you have to invest to earn 20,000 within 3 years of time. Just you will find an extension of earlier picture. Here two components are mentioned here. Invest early, though it's going to be a bigger challenge for you. You must invest early and earn higher returns. This also highly balancing exercise between risk and return. You may ask why we have to invest early due to a time value of money, that the value will grow. And whereas to earn higher returns, because you must have cushioning, you must beat the inflation rate also, by which you must be in a position to get more return, by which you will ensure a good wealth creation is taking place. Put in very simple way, invest early, earn higher returns, and that will lead to building a big wealth in future. The interesting fact is that you can do compounding. Compounding can be done biannually, once in 6 months, quarterly, even by monthly or fortnightly, once in 15 days. This problem will tell you how to make the compounding quarterly. You invest 20,000 rupees at 8% annual interest, compounded quarterly. That is 4 times in a year. How much will you have after 2 years? Yeah, the formula same one what we used for the earlier problem, the first problem. Future value that is equal to present value into 1 plus r divided by m we are putting it. Last time we used 1 plus r to the power n. Here slight changes since it's meant the compounding is happening quarterly. So it will be multiplied with m. So here we are making use of quarterly. So 4 will come. N is nothing but number of years is clearly given in the problem, 2 years. Okay, we're doing it 4 times in a year. So into 4. So that's why m is equal to 4 quarterly compounding. So just we are going to substitute the value in the formula 20,000, the present value, into 1 plus 8%. If you convert into decimal, you will get 0.08 divided by 4 to the power 2 years into quarters, 4 quarters. So we are getting the final result of 23,433.18. So what it indicates, if you make 20,000, if you make an investment of 20,000 at 8% annual interest, compounded quarterly, within 2 years, you are able to make a surplus earning of 3,433. Principal plus your interest put together, it will be 23,433.18. In the earlier slide, we have discussed about quarterly compounding, 4 times in a year. In this slide, we are going to discuss about how to compute the future value with semi-annual compounding, that is twice a year. You're making an investment of 15,000 at an interest rate of 6% per annum, compounded semi-annually. So it's very simple. Present value is 15,000, rate of interest is 6%, 0.06. Number of years 2, but you are going semi-annual compounding. As I already told you, if it is quarterly, you have to go for 4 times. You have to multiply with 4. That is the n into m. N is 2 years here into m. It's mentioned here twice year. So 3 into 2 it's mentioned. Substitute the value of present value is 15,000. 1 plus 0.06 divided by 2 to the power 3 into 2. Here one interesting fact is that whenever you do annual compounding, okay, the result will be much more better than annual compounding. So here you made it once in 6 months, and compare with the once in 6 months, 4 times in a year, quarterly will be better. So you can see 15,000, okay, it is able to yield 17,910.75 paise within the period of 2 years. So I think it'll also it is also essential to understand the benefits what you're going to get out of this one. That's very important. So I think the compounding is based on many. In that quarterly we have taken, okay, we used to multiply with the number of years into 4 times. Here biannually, okay, we have multiplied with 2. I request you to take a piece of paper and you can do the sum along with me. We started with quarterly compounding, then biannually once in 6 months. Now it's going to be a monthly compounding. So monthly compounding is nothing but 12 times. 12 months in a year, 12 times. You want 50,000 after 2 years. The bank pays 7% interest compounded monthly. How much should you invest now? To get 50,000 after 2 years at the rate of 7% interest, how much you are supposed to invest now? So future value is known to as 50,000 is given in the problem itself. Rate of interest also given 7%. And as already told you, we are going to compounding, okay, monthly compounding. So 12 times. So it's given here. And just substitute the value FV whole divided by 1 plus present value is 50,000. Then the rate of interest is 0.07. So 50,000 divided by 1 plus 0.07 divided by 12 to the power 2 years. 2 into 12. So 24 you are getting. Further simplification, you'll be getting 43,345.87 paise. It's very simple. To get 50,000 within 2 years period of time with the monthly compounding, you have to invest 43,345 now, and you are eligible to get 50,000 within 2 years. I think hope you'll understand. Started with the annual compounding, quarterly compounding, biannual once in 6 months. Now it's monthly. So you can also go further down to a fortnight, once in 15 days, weekly, daily, hourly. Compounding can be done in any way. In this slide, we will discuss about future value of annuity due. The annuity due payments may be made at the beginning of the period or at the end of the period. Here, the annuity due payments are at the beginning of the period. You deposit 8,000 rupees at the beginning of each year for 4 years consecutively in an account earning 5% interest. How much will you have at the end of 4 years? So here you must note two important points here. For annuity due, as I already told you, payments are at the beginning of the period. And you are supposed to use ordinary annuity formula for multiply by 1 plus R. Yes, and the deposit money is 8,000, which is nothing but P, or 5%. A number of years, 4 years. And ordinary annuity future value, that is equal to P into 1 plus R to the power n minus 1 whole divided by R. This is a formula we'll be using it. Please remember the formula. You can write it twice or thrice to memorize the thing. Substitute the value P is 8,000. Then 1 plus 5%, that is 0.05 to the power 4, because n is 4, minus 1 whole divided by R, 0.05. If you simplify, you'll be getting 34,480 rupees and 96 paise. So just to calculate, the annuity due, the future value due, that is equal to future value ordinary into 1 plus R. So take the calculator ready of 34,480.96 paise into 1.05. So you will get 36,205. You can work out twice or thrice just to have a copper with that. Remember the formula P into 1 plus R to the power n minus 1 whole divided by R. This slide is going to be quite interesting to you. We are going to find the interest rate. We know both future value as well as the present value. How much interest revenue generated? So that's a task now. You take this particular exercise. Invest 12,000 today, grows to 15,734 in 4 years. So 12,000, that has become 15,734. So okay, you have to find the annual interest rate. So the future value formula. Future value is equal to present value into 1 plus R to the power n. So we know we have some missing value. R is missing. So I'm bringing other side to the equation. So 1 plus R to the power n is equal to FV divided by PV. That is equal to, again, I am taking the power n to the other side. So 1 plus R is equal to FV divided by PV to the whole power 1 by n. Now I'm going to substitute the values here. Again, the round number I'm taking to the other side of the equation, it will become minus 1. So 1 plus R, okay, just I'm removing 1 from here. So R is equal to FV divided by PV to the power 1 by n minus 1. So now we are going to substitute the value. The values are given. Future value, how much we are going to get? 15,734 rupees and 40 paise whole divided by PV, present value. How much we are investing? 12. So to the power 1 by 4. Because number of years are 4 minus 1. Substitute the values, the simplification, we are able to get the calculated value is coming around 1.070. So the if you look into that, see, we have already taken the base value. So it's a 1.070 minus 1, we have to take minus 1. So 0.07. If you multiply with 100, it's going to be 7%. So from this problem, you will come to know that if you make an investment of 12,000, when it is resulting in 15,734 in 4 years, because of 7% interest rate applicable on it. Let me move on to the another typical scenario. How to calculate present value of uneven cash flows. So earlier cases we have mentioned, okay, the cash flow may be irregular, but here you may make a one-time investment also, investing 50,000 and expecting the maturity after 5 years, how much you are going to get it. Or 75,000 you are going to get it after 5 years. A particular interest rate will be given. How much you are supposed to invest right now. All the thing we have taken. So now this is a scenario where the present value of uneven cash flow. Say for example, you have year one 5,000 and subsequent year you have 6,000, 7,000, 8,000 respectively. So second year 6,000, third year 7,000 and fourth year 8,000. And here it's mentioned as discount rate 7% because we are applying the discount rate to pull down the bring down the value. So just you can recollect the formula of the present value. We are applying the discount factor. You can see it's always in the sigma that will be represent the total of. Here we are using almost the same kind of formula. CFT, ST is nothing but time divided by 1 plus R to the power T. I think the next slide will tell you, the clear-cut information about this computation. You are requested to calculate the present value when you have a cash flow is not even. The first year cash flow is 5,000, second year 6,000, third year 7,000, fourth year 8,000 as far as this example is concerned. Discount factor, yes, is given in the problem itself 7%. So 0.07 we have taken. So first year there will not be any changes in the amount. 5,000 will be 5,000 will be taken. We are applying the discount factor. There is 1 plus R. So 1.07 to the power. Okay, here you can see no, its power will be only 1. So 5,000 divided by 1.07, 4,672 rupees and 90 paise. Coming to the second year, the T, okay, in the formula that stands for the period, second year, 2. So 1.07 to the power 2. If you multiply twice, you'll be getting 1.1449. 6,000 divided by 1.1449, that is equal to 5,240.24. Likewise, repeat the same for third year, 1.07 to the power 3. Okay, you'll get 5,714.2529 paise. And fourth year, yeah, you are able to get 6,103.95 paise. And I'm going to sum up all the value. See, first year the value has become 4,672, and second year 5,240, third year 5,714, and fourth year 6,103. Put together, the total amount has become 21,731.38. Simply apply the discount factor, then you go for a cumulative value of all computed items. So that will help you, to calculate each present value. Hope you might have worked out the problem along with me. When I'm making a tutorial, you might have followed me. I'm able to see, couple of computations you have made. Just to sum up, or to have a better understanding about the time value of money. Rupees 100 of today. If you have 100 rupees now, it's going to be 133 rupees after 3 years. How it's going to happen? Today you have 100 rupees. Say for example the interest, or you can say the growth rate expected 10%. So 100 by applying a 10% at the end of the first year, it will become 110. For the 110, you'll be applying 10% at the end of second year. Likewise, third year, you are able to get 133 by investing 100 now. I think this will tell you the entire story about time value of money in a simple way. All the best for your examinations. God bless. MBA Decoded, the series of video, is from Dr. Karpaswamy Ramanathan, a renowned professor who is having 25 years of rich experience both in industry as well as academia. You can like, comment and subscribe for this particular channel, MBA Decoded. God bless.